In this lesson, we'll learn about vectors and their operations, ベクトルとその演算, and vector decomposition, ベクトルの分解. First, let's talk about the decomposition of vectors. Given the two vectors, vector A and vector B, let's represent other vectors. Suppose that the two vectors, vector A and vector B, are not vector O and are not parallel. In this case, the arbitrary vector P can only be expressed as vector P equals S vector A plus T vector B, where S and T are real numbers. Next, we will explain how to do a proof of a vector decomposition. As shown in the upper right figure of the screen, we'll have vector A equal vector OA, vector B equal vector OB, and vector P equal vector OP. If we let A prime and AB in the intersections of the line passing through the point P and parallel to the lines OB and OA, and the lines OA and OB respectively, then we can express it as vector OP equals vector OA prime plus vector OB prime. Let's have that be our equation 1. Where the point A prime is on the line OA and the point B prime is on the line OB, there's only one pair of real numbers, S and T, that satisfy vector OA prime equaling S vector OA and vector OB prime equaling T vector OB. Substituting these two equations into equation 1, we get vector OP equals S vector OA plus T vector OB, or in other words, vector P equals S vector A plus T vector B. Now let's talk about how to use vector decomposition. In the regular hexagon A, B, C, D, E, F, since vector AB equals vector A and vector AF equals vector B, then vector AE can be expressed using vector A and vector B as follows. Vector AE equals vector AB plus vector BE, and also equals vector A plus 2 vector B. Now let's try the practice. Press the pause button and try to solve the practice problem. Once you are finished, press the resume button and mark the ones you got correct. Now let's check our answers. Vectors AD, DF, and CE will look like what's shown below. Were you able to answer them correctly? That concludes this lesson.